Hello, today we'll be doing a couple of problems in this video and upcoming next videos. Here we are focused on hypothesis testing for one sample mean. Please go through this document and you'll have sufficient idea about what to do and what are the steps that you need to go for. Okay. And I would like to make things much more easier. So that's why what I will do is I'll just give you a table. And we will be using GeoGebra graphing calculator. Okay, so here hypothesis testing one sample mean. For one sample mean, if the distribution that you have chosen is normal, then in GeoGebra probability calculator you go for g-test of a mean, which is you go to this website geogebra.org/classic-probability and click on this statistics. Okay, then you will see this drop down menu and click on those. If the distribution is normal, then you go for z-test of a mean. The distribution that we want to work with is student t distribution, then we go for t-test of a mean, which is you click on drop down menu and go for t-test of a mean. Similarly, if the distribution is a proportion distribution, then we go for g-test of a proportion. Okay, so click here and go for g-test of a proportion. Okay, those are the things that makes things much more easier. Okay, let's go to the first question. A college football coach records the mean weight that his player can bench press is 275 pounds with a standard deviation 55 pounds. 3 of his players thought that the mean weight was more than that amount. Okay. They asked 30 of their teammates for their estimated maximum lift on the bench press exercise. So the data ranged from 205 pounds to 385 pounds. The actual different weights were frequencies in parentheses 205 for 3 players, 215 for 3 players, and so on. Conduct a hypothesis test using 2.5% level of significance to determine if the bench press mean is more than 275 pounds. So first of all, let us write down the hypothesis meaning. So this is, we can see that in that question, it is simply saying, determine if the bench press mean is more than 275 pounds. Okay, 275 pounds. Bench press, if it is mean is more than 275 pounds, then that's one of our hypotheses. And its contradictory hypothesis is, of course, mu is less than or equals to 275 pounds. Okay. All right. Now, here we clearly know that by this question, it is already saying that the mean weight that his players can bench press is 275 pounds. So we would assume that this one is simply mu equals to 275 pounds. So these two are contradictory hypotheses. So first of all, we know that the equality sign is for null hypothesis, and the alternate hypothesis is mu is greater than 275 pounds. Okay. So the college coach to be 275 pounds, players think more than 275 pounds. Okay, so why I wrote down these two hypothesis, null and alternative hypothesis, and their description is description will help us to write down the conclusion at the end. Okay, so that's it. All right, and here you can clearly realize that since the null alternative hypothesis is saying it is greater than 275, meaning this distribution will consist of this will be a right tail distribution, something just like this one. Okay, right, it will be something just like this. The shaded portion, we'll go for shaded portion. Okay? So that's why we can say that this is a right tail distribution. That's a right tail distribution. Since the mean and standard deviation is already given, so this is a normal distribution. Since normal, the distribution that we are working with is the sampling mean distribution for this distribution is, then x bar is players can lift. Okay, so that's what x bar describes, and mathematically or statistically we can say this is normal distribution 275 that comes out from the from the original population mean, or you can simply say that this comes from the null hypothesis. Okay, and we know that the population standard deviation is sigma, sample size is n. So we know that n equals to 30, that's sample size, n 275, and this is what 55. Oh, this was 55 over root under 30, right? So that's it. Okay, then this would be n 275, so that's 10.0416. 10.0416 is the sample size we have taken is 30, and x bar, its mean is 275, and its standard deviation is 10.0416. Okay, so that's it. Number 3, we need to figure out the p-value. Okay, alpha equals to 0. Alpha is 2.5% significance level, which is alpha equals to 0.025. P-value, let me indicate this p-value by p equals to what? Probability of x bar being greater than the mean weight of the given sample. Okay, so we know that this is the data that we need to work with. These are the 30 data points that we need to work with, and here in Microsoft Excel I have already populated all the data. Okay, so 205, 3 of them. Okay, 205, 3, 215, 3 players. Okay, hold on, 215, 3 players, 225, 1 player, and so on. Okay, so please type this data manually in Microsoft Excel, then you can clearly find out the mean. Mean or average is simply what? That's you can clearly realize that's 286.166. okay, so let me write down 286.17. okay, and I also want the standard deviation. Standard deviation is what? So for standard deviation, we know the formula equals to STDEV array 1. So that is A30, since there are 30 data points, right? So you can see that. Okay, so 55.8984. However, this may not be needed. Okay, so 286.17. So probability of getting x bar to be greater than 286.17. The distribution would look something just like this one. So this is 275, that's the mean, and 286.17 would be something just like this, and we are looking for the probability of this shaded area. Okay, so which is okay. Now let us write down everything in since the distribution is normal, so we go for G test of a mean. What is the null hypothesis? Null hypothesis is 275. Okay, and we know that we want greater than, since the players, they were skeptical about the mean weight, mean bench press weight, so they thought that it's greater than 275. Okay, so the mean is of course 286.17 for that sample, right? For that sample, 286.17. Standard deviation is what? Standard deviation is of course 55 point something. Hold on, 55.8984. Okay, and total number of players was 30, right? That's it. So you can see that the mean is this much, standard deviation this much. Now this standard error, we don't need this right now. We need this standard error only for coming up with confidence interval. Okay, so that's it. Then n is 30, that's the sample size. Z is the G value, or Z statistics. Okay, the test statistics is 1.0945, and the p value is 0.1369. 0.1369. So p value is 0.1369, which is approximately 39.69%. Now you can clearly realize that alpha is 2.5%, however p is 13.69%. So alpha is less than p. P is not significant in this case. So we say since alpha is less than p, we do not reject the null hypothesis. Okay, so that's what it means. That is to say that if we want to conclude, then what we can say this is, since we can simply write for 2.5% confidence level, significance level, there is no sufficient or enough evidence. Yeah, let's write sufficient evidence. The mean weight of bench press greater than 275 pounds. 275 pounds. Okay, so we do not reject the null hypothesis. Means there is no sufficient evidence that the mean weight of bench press is greater than 275 pounds. Okay, so that's what it means. Okay, now one clear thing that we need to realize is p-value. P-value talks about the significance level. Okay, whenever the p-value is less than 5%. Okay. Usually the significance level that we by default try to choose is 5%. If the p-value is less than 5%, then it has some significance to the problem. However, if the p-value is more than 5%, then it does not have any significance. Okay. All right. So here we can say that p-value is greater than 5%, no significance. And p-value is less than 5%, yes, significance. Okay, there is some significance. Okay, but how? Okay, now this 5% can change. In this problem, it was 2.5%. However, by default, usually if nothing is given, if significance level is not defined, then we can definitely go for this 5% criteria. Okay, I hope this will help you. Thank you so much.